So let me just quickly give you another example of the way in which you fill up electrons in a given atom. So here I have the book, the textbook for you, and here I don't think you have the textbook with you, but yeah, I'll just upload the picture of this table here. Here I have the table, and this table, if you can see, I'll just upload it on the page also. Here you have the name of the element, and here you have a list of the elements, the various names of the elements, and also you have the symbols for that element. So what does the symbol mean? Well, each time it is a very tedious task to write the complete name. So if I have to tell you this is hydrogen, this is oxygen, this is all that, so it will be a long time if I write hydrogen, the complete name. So yeah, just like you guys have nickname, right? It is very tedious to call everybody with their complete name, so we keep nicknames, and nicknames are fun to use and easier to call out, right? And also easier to write. Similarly, elements also have nicknames. So what is the nickname of hydrogen? Well, hydrogen, such a long name, and what we do is we simply remove the remaining hydrogen and we're left with the H, and that H is simply the symbol of hydrogen. It is the nickname of hydrogen, H. Simple, right? Now if we move on to the next element, the element with the atomic number 2, which has 2 protons, it is called helium. Now if again I follow the same rule, I remove the remaining letters, well, this becomes H and H, same, but you know, two elements should not have the same nicknames, because that will just be confusing. We don't know that, so we want these two to have different nicknames or different symbols. So what I can do is, so this is helium here, instead of removing the complete name, I'll just remove this much and leave the first two letters, and obviously just like your names start with the capital letter, we'll start the name of the nickname of the element with the capital, and the remaining E or the second letter will be a small one. So HE, capital H small e, is the symbol of helium, and so on and so forth. So the third one is lithium, LITHIUM, lithium. And again, what I can do is I can remove the remaining name. Now let me just keep the first two, L and small I. So now you'd be asking, why can't we just call it a simple L? Well, I don't know why scientists do not call it simple L, but yeah, that is how it is. So these are the nicknames given by scientists, and we just have to follow them. So lithium is called simply capital L and small I, Li, lithium, and so on and so forth. Every element on the list has a nickname called a symbol, and you can just look at the table and figure out the symbol of that given element. And so sometimes, you know, they have weird nicknames. For example, sodium, you would expect sodium to have a nickname of SO or S, something like that, but people just call them Na. Now that would be very weird at first, but yeah, it has a logic behind it, which is that so sodium has another name in Latin, which I don't know for now, but in that language sodium is called something that starts with Na, and that is why it is called Na, right? So even you guys might have very weird nicknames that would not match with their names, but you know, similarly elements also have such weird nicknames. But yeah, that's it for the nickname part. Then the table also shows you atomic numbers, which simply tells you the number of protons that particular element has. So for example, magnesium, which is another element called by the nickname Mg, capital M small g, has an atomic number of 12, which simply means that magnesium has 12 protons in its nucleus. Number of protons, 12. And if you move further in the table, number of neutrons, also 12 by chance, and number of electrons, again 12. So 12 are equal protons and equal electrons, so it is neutral. And yeah, so that is the basic idea. And here you can look at the distribution of electrons. So how many electrons are inside the K or the first shell, how many are there in the L or the second shell, how many in the m and how many in the n, and so on and so forth, right? That's the basic idea. And yeah, just to wrap it up, apart from telling you the symbols, I'll just give you a small example of how we have to fill up the electrons in the various shells. So let me take a large one this time. Let me take the last one in the list, argon. Argon, also known by the symbol Ar, and its atomic number is 18. So if I draw its nucleus, atomic number 18. Atomic number is 18 means 18 protons. So 18 p inside this nucleus. So you have 18 protons. And let us look at this argon. Argon by chance has, it turns out it has 22 neutrons. Weird, right? Well, I told you it's not a very it's not a rule that the number of neutrons and protons has to be equal. This particular isotope has 22 neutrons. There might be some isotope that has equal number of protons and electrons in case of argon, but this one that they have given in the book has 22 neutrons. So yeah, let's just go by that, 22n. And just to keep it electrically neutral, we'll have to put in 18 electrons. So that the net charge is 0. Now how do I put in those 18 electrons? Let me take the first shell here. The first shell is 1. How much is its capacity? Well, we know that the capacity can be found by this formula, 2n square. N in this case is 1. 1 square is 1, and 1 into 2 is 2, right? So I can fit in 2 electrons. So this is the first electron, this is the second electron. Now I have fit in 2 electrons. 18 minus 2, 16. So I'm left with 16 electrons now. Now let me take, so this shell is filled up. I'll draw the next one. This had a capacity of 2. Now the next one, 2n square, and this one is the second shell. So n for this one is 2. 2 square is 4. 4 into 2. 2 4s are 8, right? So this shell has a capacity of 8 electrons. Now I have already filled in 2. The third one goes here. Third, fourth, fifth, 6th, 7th, 8th, 9th, and 10th. Now I have filled in 1, 2, 3, 4, 5, 6, 7, 8. After filled in 8 electrons in the second shell, so now the second shell is also filled up because it has a capacity of 8 electrons, and I have done that. So till now I have been able to complete 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 electrons in total. I had 18 in total. I have filled up 10. So now I am left with 8 electrons. I'll have to move to the next third shell. N for this one is 3. 2 into n square, right? Which means 2 into n is 3. So 3 square is, well, 9. And 2 nines are 18. So this shell has a capacity of 18 electrons. I am left with only 8 electrons. So let me fit in. So obviously those 8 can easily fit in because this thing has a capacity of 18. I am left with only 8. So I can just fit in 1, 2, 3, 4, 5, 6, 7, 8. That's it. And now if I count in the total number of electrons in the whole atom, I see 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. 18 electrons filled up in the atom. And according to the rule, that is all that I was there to tell you. This is how you fill up the various orbits or the shells in a given element or a given atom. And I hope by using this method you can fill up the electrons in any given atom. So yeah, that is how you fill it up using that simple formula of 2n square. And yeah, that's it for this video.